Yeah, good afternoon, everybody. Today we are going to discuss about the block diagram of a control system. Basically, a block diagram is a pictorial representation of the functions performed by each component of the system, and also it shows the flow of the signals from one end to other. In block diagram, the consists of system consists of many components. These components are linked together to perform a specific operation, so that each component can be represented with the help of the individual block. So what is the use of the block diagram reduction? Here, block diagrams of some of the systems turn out to be complex such that evaluation of their performance requires simplifications of block diagrams, which is carried out by block diagram arrangements. So here we need to know the advantages of the block diagram concept. Here it is very simple to construct the block diagram for complicated systems. Individual as well as overall performance of the system can be studied by using transfer functions shown in the block diagram. So overall closed loop transfer functions can be easily calculated using block diagram rules. The function of the individual element can be visualized from the block diagram. So these are the advantages of the block diagram concept. Similarly, the disadvantages of the block diagram concept are block diagram does not include any information about the physical construction of the system. So this is the only one drawback in the case of block diagram. Here we need to know, yeah, we are having the basic components of blocks diagram are functional block, branches, summing point, and arrows. So first we should know the meaning of block or functional block. It indicates the function of a particular system. So RFS is the reference or controlling variable here, and GFS is the meaning for transfer function of the particular system. Then the CFS is the meaning for output or control variable. If you observe this diagram, here we are showing some input signal as RFS with the transfer function as GFS. Finally, we are getting output which will be representing with the help of the CFS. So here another point is summing point. So summing point is having the symbol like this. Here RFS and two more signals are added to by using this summing point to produce some output. Next one is takeoff point. Takeoff point is having a node here. So here we before the node we are having some takeoff point, so that it is easy to reduce the block diagram size also by following different rules. So here the steps to reduce the block diagram: reduce the series blocks, reduce the parallel blocks, and reduce the minor feedback loops. As far as possible, shift the summing point to the left and takeoff point to the right. So repeat the above steps till the canonical form is obtained. First we will see different rules for reduction of block diagram. First rule: if the blocks are arranged in a cascaded form, then we are having simplification like this. Here if you observe this, here the block G1 and G2 are in the cascading manner with the inputs as X and output as Y. Now we are taking these two blocks as a single block with the multiplication of the two gain values like G1, G2. Second rule: if the blocks are in parallel mode, then the blocks are added or subtracted depending upon the summing point signal like this. So with the help of the summing point, we will add G1, G2, or we will differentiate G1, G2. Now we are taking it as a sum of G1, G2 with the input as R of S and output as C of S. Third rule: moving the takeoff point after the block. Here, if you observe this takeoff point is available ahead of the block. This block will be having uh, yeah, like this. Now this will be having with the help of another block with the gain 1 by G, we will have the after the block also. Now here we are having some closed loop function with the gains G1 and G2. Now we are having these two will be added with the symbol G1 plus or minus G2 here. Next one, moving summing point after the block. Here we are having the before summing before the block we are having summing point with the inputs as u1 and u2 with the output as y. Now this will be shifted after the block like this. Another one, moving summing point ahead the block. If you observe this figure here, we are having input as u1. This will be applied to the functional block with gain g. This will be shifted before the block by taking 1 by g as one more block. So using these block diagram reduction techniques, you need to find the transfer function of this given block diagram. If you observe this block diagram, here we are having two summing points and three gains with each individual blocks g1, h1 and h2. Here first rule, eliminating the feedback loop. Here we are eliminating this feedback loop, that is called g1 by 1 plus g1 into h1. We are taking it as one block. This block is also having one more feedback loop with the gain h1 here. Now this will also be taken as g1 by 1 plus g1 h1. We are having g of s. Okay, na? Now we are taking this c of s by r of s as, if we consider this total block as g and this as small h. Now g by 1 plus g into h, like this. So g1 by 1 plus g1 h1 with h1 is equal to the output. We are taking it as ratio of c of s by r of s is equal to g1 by 1 plus g1 h1 plus g1 h2. So finally we are taking this as a block, a single block, with the input as r of s with the output as c of s. Now g1 by 1 plus g1 with the h1 plus g1 h2. So this is the way to reduce the a complex block diagram into smaller one. We are having one more example here. With the, in this case also we need to find c of s by r of s for the closed loop transfer function. If you observe this block diagram, here we are also having one closed loop here, one parallel combination here, and one more closed loop here. So we need to have first these two will be in the cascading manner. So we are taking g1 with g4 as a single block. After that we are having the g2 and g3 here are a parallel combination. So we need to add these two. G2 plus g3 will be having, g2 plus g3 will be having this summing point. Now from this summing point we are getting one block with gain as g2 plus g3, but here we are having cascading manner, so we need to product these two gains as single block. Now if you observe this, this is making a loop with h1 gain, so we need to remove or we need to eliminate this feedback loop. Now this one given as g1 g4 by 1 plus g1 g4 with h1. So this is the equation here. Now this is now cascading with this block with gain g2 plus g3. Now this total box value and this value will be multiplied. Now we are getting like this. Now this total one will be having one more loop with the h2 gain. So we need to remove that loop 2 also. From that we can write g1 g4 by 1 plus g1 g4 h1 into g2 plus g3 whole by 1 plus g1 g4 by 1 plus g1 g4 h1 with g2 plus g3 into h2. So this is the value of the closed loop transfer function. Guys, understand? May know the meaning of functional block, for what purpose it is using. Can I expect answer from you? Yeah, let me explain. Here the functional block indicates the individual block which is having input signal, which is producing some output signal, which also having some transmittance, also known as gain. So that here also we are having beautiful example. Here we are having G1 with H1 is these two are making some no, we need to have addition of these two, that will be having loop combination here, and also it will be having some cascading loop here, and this also making one more loop. So here we are having three main loops, so we need to remove those also. First, shifting summing point S2 to before the block G1 and shifting the takeoff point T2 after the block G4. Here, by having this step 1, this will become as 1 by G1 with H, also 1 by G4 with this one. Now, these two are in the cascading. We will see now. Exchanging the summing points and takeoff points using associative law and combining the series blocks, we get H3 by G1 G4, and also making G1 G2 with H1 as a loop. This also having loop here. So eliminating the feedback loop 1 and 2 here. Now we are getting this as a equivalent form, G1 G2 by 1 plus G1 G2 with H1. This also second loop 1, G2 G4 by 1 plus G3 G4 with H2. Now these are having cascading manner, we need to get their product. Now this is the equivalent of this product, these two blocks. Now this will be having uh, loop with this one. So last eliminate the feedback loop with loop 3. Now G by 1 plus G H. In that way we are getting CFS by R of S as G1 G2 G3 G4 by 1 plus G1 G2 H1 into 1 plus G3 G4 H2 whole by 1 plus G1 G2 G3 G4 by 1 plus G1 G2 H1 into 1 plus G3 G4 H2 with the multiplication of H3 by G1 G4. By solving this entire equation, we are having CFS by R of S as G1 G2 G3 G4 whole by 1 plus G1 G2 H1 into 1 plus G3 G4 H2 plus G2 G3 H3. So these are the required block diagram reduction rules to solve the a complex block diagram into simpler one by following specific block diagram algebra. In this way we are having different problems. Here in this video I am showing the example of block diagram reduction rules. This is first one, first rule, combining blocks in cascade. So this is the original block diagram. After this we are having equivalent block G1 G2 with single gain, combining blocks in parallel manner or eliminating the forward loop. So if these are the uh, blocks which are connected to summing point like this. Now we are taking combination of G1 plus or minus G2. Now the output will be taken as G1 plus or minus G2 with input X. Similarly, third rule, moving a pickup point behind a block. Here, ahead of the block we are having a moving point. Now this will be taken with 1 by G as another block. So this is the way to get the output value V. Y is equal to G into U. This is also equal to G. U is equal to 1 by G with Y. Fourth rule, moving a pickoff point ahead of a block. Here we have after the block a moving point is there. If you want to move this to ahead of the block, this is the way. From this we can get Y is equal to GU. Next, moving summing point behind a block. Here we are having the in front of the block. If you want to move after the block, this is the way. We can take one more block here, G comma G. Now output Y will be equal to combination of G into U minus U1 minus U2. Similarly, last one, moving summing point ahead of a block. Here U1 is equal to G. We are having in front of the summing point. Now here the summing point is available after the block. If you want to move to in front of the block, we need to take one more block with the gain 1 by G. Now this will become as G into U1 minus U2. So these are the important terms and rules for the block diagram concept.